Hi everyone, I'm Martin and welcome to another great edition for Astronomy for Beginners. And today I've got something fantastic to show you. Now this is a modification that you can do for yourselves and you wouldn't believe what this mod can do. Now if you're owner of a DSLR camera, you'll probably find the main problem is if you take a look at these pictures I've taken of dark frames. Now if you have a look at these dark frames, you will see in those dark frames noise. Now to take dark frames is you take them with the lens cap on your camera. Dark frames are used to process your images when you're taking light frames of deep sky objects. Good thing about dark frames, they will show this noise really clear. So I'm going to show you a couple of pictures on what I'm talking about. So now you see what this noise is. Noise is basically these hot pixels that form into your images, and this noise will interfere the resolution of your pictures, your picture quality. I noticed when you increase the ISO to 3200 to 6400, more of that noise becomes more apparent, and higher exposures will give you more of that interference. So longer exposures will also increase this noise. And basically this noise is created through the electronics from your camera. This interference will get worse and worse as you increase the exposures to 5 minutes and 10 minutes exposure times. Now the thing is with CCD cameras, these are dedicated for astrophotography, are usually very good, and they have a cooling device like a Peltier cooling device that helps these CCDs cool down the electrics or reduce or totally eliminate some of this noise effect. However, CCD cameras dedicated for astronomy are very expensive, and you can expect to pay a good one for around about £400 right up to about £2,000, maybe £3,000, even £4,000. And that is beyond most amateurs' budget, especially for a beginner or a newcomer or for a guy who's on a limited budget. It's far too much money. And the DSLR camera seems to be the only option for a lot of astrophotographers. Now the good thing about DSLR cameras is they are very good at taking high-res images of deep sky objects with really good detail. Because noise is the biggest letdown for a DSLR camera, I did a lot of research to try and find a possible way, and believe me, there is no easy way, and it is quite hard to find a way to cool a DSLR camera. And here it is. Now if you're owner of a Canon 600D or an owner of a 700D or a 750D or a similar DSLR camera which has the flip screen, okay, so you can flip the screen out, you're in for some luck. Because with this modification, if you take a look at the back, you can see I fitted a cooling module for this camera, and the good thing is it's a heavy duty one, so it's very good at cooling, okay, with a bigger fan. It's got the Peltier element inside, and it has a tech control module. In other words, this thermal electric controller here will be able to regulate the cooling. So this is not just your standard Peltier cooling system that you saw on the last video that you saw with the Zoo ASI 120. This will enable me to control the temperature of my DSLR camera. Now the good thing about this modification is I've done it in a way so that you do not take this camera apart. Now I've heard through a lot of people, and I totally agree with what they say. There are some people that say, well, the only way to cool a DSLR camera is to do the finger modification, which is the cold finger modification. But unfortunately with the cold finger modification is you need to strip down the camera, strip down the electronics to get to the sensor, and then take the sensor apart to fit a way of a copper wire or plate so that a Peltier cooling system can be in place. Now that is the best way to do it, but the main problem with the cold finger modification is you might avoid the warranty of your camera. Okay, you don't want to do that, especially with this camera I've done. I mean, this is a modified DSLR camera which has got the Barda filter in there. Now I also had a guy do the work for me. I don't want to be stripping out this camera just to place the cold finger mod in there. Especially the amount of work that's been put into this camera. I don't want to waste my money on that. So I found a way, and you'll be able to see it, and you'll be able to undertake it for yourselves for not much money. And believe me, you can build this device, this cooling device yourself for not much money, between 40 to about £46. Now I have different price ranges and different part numbers and costings, and there are additional items that you may want to fit but you don't have to, but it will increase the price just a little bit more. But it's not going to cost you no more than £60. But a lot of the items are very expensive, and you'll get to see why they're expensive. Okay, so, but still a cooling module for less than £60, and it does everything you require from it. Now if we take a closer look on this picture, this is taken with this modification and with this ISO, and it's cooled down to a certain temperature, and you'll see in the picture, and you'll see the brief descriptions that on below on how much this is cooled down. And believe me, what a difference it makes. Despite not being a cold finger mod, this has worked absolutely amazing. I've never ever thought it might work, but it did. And if you follow these guidelines, follow all the instructions, make sure you order the parts exactly that I've done, okay, go through it all, you can make this very, very easily and save yourself cash in the long run. The modification is relatively basic, believe it or not. It looks complicated, it does look professional, and it looks as if it's part of the actual camera itself. I have seen something very, very similar to this, and there's a lot of companies out there that are selling these for a lot more money. Unfortunately, I can't tell you what these companies are, but I can guarantee you now, you can do this quite easily. It might not be as effective as some of these cameras are, but it's damn sight massive improvement what I've achieved for this camera. Now if you're interested to do this, please undertake this. It is worth that step. But I must warn you now, don't rush into this. Take your time when you're building this modification. Follow exactly what I'll show you, and you too will have a cooled DSLR camera for not much money. Save yourself mega bucks in the long run, and you'll have great images in the process. Now this is just a simple modification, and it might not be just as effective as cold finger mod, but the good thing about this modification is it's cheap, it will cool down the camera quite effectively. The good thing is you're not going to strip out the camera at all to also avoid the warranty, and also it's easy to install, and it's so easy I can just take it apart if I don't want the cooling module. It's so simple. That's how effective it is. But what we're going to do is, as we go through the video guide, so I'll show you the step-by-step instructions like always, the parts you're going to need and the tools you're going to need and the equipment to do the job. And in part 2, obviously when it comes out, so I'll show you how it performs and also briefly describe my findings. When I make modifications, I make sure that they work for you and they're tested out so that you don't waste your money or your hard-earned cash. Yeah, you want a modification that works. And for me, I'm prepared to take that chance to deliver the goods, to show you guys and girls that you can do this with confidence, build a modification that's going to work. If you follow exactly what I tell you, you're guaranteed you're going to have a really good cooling module for your DSLR camera. So if you're interested and you want to do this modification, please keep watching and take note of all the things I'm going to say, because believe me, this will change everything to your images, and believe me, you will be amazed what this camera can do now. So what we're going to do now is we're going to take a closer look, show you guys and girls what you can do for your DSLR camera and have yourself a cooled DSLR camera made for astrophotography, for deep sky objects. So let's go and let's move. The parts you're going to need to make this DSLR cooling mod continues as follows. First off, you're going to require this handy piece of equipment. Now this is a Duroc micro digital thermostat, which is 12 volts by 50, 110 degrees temperature cooling controller module switch with a 10 amp 1-channel relay. It sounds a bit of a mouthful, but basically what this is a electronic component which can be used to control the temperature control of your Peltier cooling system. It has a built-in temperature probe, like you see here, which will detect the surrounding ambient temperature within your camera, and what it does is it will control the Peltier cooler, the actual element, and the fan. And basically what it does, it allows you to control the set temperature so that it maintains it at a fixed temperature, particularly if you're overcooling stuff. You don't want that Peltier to overcool your camera and turn it to a block of ice, in other words. Now it looks complicated at first, but you can buy this from Amazon. Okay, if you go online you'll be able to research that. It's very small, it's very compact. Okay, reason why I got it is because it's a fantastic little package. I don't want a massive project box with a massive circuit board of this temperature cooler. I want something that was small and compact. Here it has 3 microprocessor buttons. Okay, these are little switches. There's 3 switches. The main problem with this device is that you can order online little press buttons, but unfortunately these are very close together. You're going to have to make some buttons yourself. Okay, so, and the other disadvantage is the actual relay here sticks out. Now I don't know why it sticks out, but I have to use some female spacer electronic standoffs, which is the printed circuit board hex screws, which are 15mm long times 4, and these are metric free. I have to use these so that I can fit these in the project box. Okay, this will become apparent when I assemble the circuit together into my project. Okay, so it does have a few disadvantages of the compact size. However, it's a one-piece device, this circuit board. Okay, it's all clip-in. It has connections where you can connect your positive and negative power, and you can connect your Peltier cooler and fan combined. Okay, so you can actually screw this together without any soldering, which is quite handy. If you go online, you'll be able to buy one of these. Okay, but you need a temperature cooler so that it will control the Peltier, so it doesn't overcool it and it doesn't warm up. So basically you set the temperature, and the temperature controller will regulate it throughout the night. Okay, very handy to have. Believe it or not, a lot of cooled CCDs or dedicated Astro cams will have a tech cooler controller built in. Okay, it will either be in a controller box or it could be built in the camera itself. But it's a basic method of controlling the Peltier, so you're not going to overcool it and then risk damaging the electronics by freezing it up, creating more moisture. You don't want to do that. There are different variants. The bigger ones are slightly bit bigger than this, but it means you need to put a bigger project box. But however, the bigger ones will have the micro switches not close together, and the actual relay itself will be soldered from behind. So there's no need to invest in these female brass PCB spacers. Okay, so that's the advantage if you get the bigger ones, but again, expect to pay a little bit more. Now this is a CPU cooler, which is a Coolmaster, and this is a DP5 5G 11B heat with a heat sink. The actual size dimensions of this heatsink itself has a 60 by 60 by 25mm in-depth heatsink. Okay, it's a CPU cooler. Okay, and it has got a built-in fan. Now the fan is quite adequate. It's got a 12 volt fan. It's 50mm. We'll cool the actual unit, the fan, at 5,000 RPMs, and it's a silent driven fan. However, the fan is a bit on the small side. You may want to use it, but when you buy this CPU Cooler Master, it all comes together as a package. Okay, it does actually work out cheaper in the long run if you get a CPU cooler set. Now, depending on the size of your camera, depending on the size dimensions of your heatsink and your fan. But however, I've did a lot of research. I mean, I could use this fan, but to be honest with you, I've looked into getting a bigger fan, which is the StarTech.com 60mm fan. So a bit of an upgrade on the 50mm fan. I've gone for a slightly bigger fan, which will allow me to have a lot more cooling. I'll be able to operate at 5,000 RPMs. Okay, it is 60mm and it's 10mm thick, and it's got a 3-pin connector. But don't worry about the connector being 3-pin, because with this kit alone, it does actually have its own connection to 2-pin. But again, it's a ball bearing fan, and it will, because it's bigger, it will assist in a better cooling. Here on the heatsink itself, I can basically mount this over the top and use screws. Okay, and I can screw this in, right, and as you can see there, it just covers the heatsink over, right, and it's a lot more coverage and better cooling. So the next item, and this is the main Peltier cooler itself. Now this is the Tech 12704 thermoelectric cooler Peltier module. It's 4 amp and it will give out a maximum of 15 volts. Right, this will operate quite sufficient. Alright, and as I mentioned before in my last video guide, this is a slightly bigger Peltier cooler. Alright, this is slightly bigger and it's 40mm. Okay, so it's quite a big, ample Peltier cooler. Alright, but again, still remain the 4 amps. You can get bigger elements of Peltier coolers, but I went for the 4 amp instead. Alright, I didn't want to go anything too bigger, because if you start putting bigger components, you end up drawing a lot more power. So I went for the 4 amp, okay, which is more than adequate. And as I mentioned before in my video guide, this is a very important component. Without it, you can't get the cooling efficiency. Now, as you can see here, the one that's printed on the printed side is usually the hot side, okay, and on the other side is usually the cold side. Okay, so that's the difference between if you can tell which is the hot and which is the cold. And again, I will test that with a little battery just to prove if it works or not, which side is which. Okay, just make sure, don't relate to the actual printing, because you might find that the printing might also have might be the cooling side. Okay, so just make sure you find out which side. We want the cold side more than anything than the hot. Alright, so that's the Peltier cooler. The next item is optional, and again, I've got the 60mm metal fan, which is protects the fan and stops your fingers getting trapped. And again, it fits over there like so. Alright, you don't have to buy it, but I think as a precaution, there's a couple of pence more, it's well worth getting the fan guard. This is the ABS black plastic electronics project box. Now this sizes is 79mm long, 61mm width wise, and depth wise is 40mm. This has a removable lid. Now as you can see here, it has screws, okay, in place. Now I've already remarked my position of my printed circuit board, because basically my digital thermostat controller circuit will be inside this box, and I've already marked out and drilled out holes of where the actual printed circuit board is going to be mounted. I have used a Dremel with a milling tool. I even cut out the actual screen so you can see the LED screen display, and I've cut out 6mm holes, alright, to allow me to so in line with the microprocessor switches. Okay, so it's already pre-cut out, and as you can see, if I remove the screws, alright, it has its little lid which I want. Okay, and that's basically with all my electronics and everything going to be coupled inside this box. So again, you need to invest in one of those. The next part you're going to need is this. This is a cigarette adapter. Okay, the good thing about this has a on and off switch built in. Okay, this can also work at 12 to 24 volts as well. Alright, and again, it has a built-in inline fuse, alright, a 4 amp fuse, and this is a 3-meter cable as well. So it's got plenty of cable. Alright, you can find these in a lot of good electronic stores. Now again, this is an optional part. Now with the actual circuit, you can actually rewire this all together by screwing it all together onto the circuit board and everything else. However, this is optional equipment. I got myself a panel mounted 2.1mm DC power socket. Now this is optional, but basically I just want my cigarette cable, my cigarette adapter cable, so that I can connect a jack plug. okay, and I just want this socket mounted onto my box. Alright, so I can plug in one of these, which is the 2.1 5.5mm male jack plug or DC power socket. Okay, so basically when I rewire this together, I can connect this straight onto my project box of my cooling mod. Alright, I find it a little bit easy, so you can disconnect the cable, but you don't have to do this. These are optional components, alright, so you don't have to include these in your project. So again, for me, I went for a little bit extra just to make my project just a little bit better. Now, as I mentioned before about the actual buttons being very close together on the micro switch on your thermal cooler circuit board, I've got myself 6mm aluminium rod round end bar. Okay, you don't only need like about 50mm long, and basically I've cut these to about 10mm long. Okay, and basically they're going to be my little buttons. Now, because the microprocessor has springs in the actual switches itself, alright, you can't get anything like smaller, alright, and these were the only ones I can look into. And the good thing is you need to include 4mm O-rings, alright. This will become apparent, again, cost a few pence, but these are going to be my little buttons so I can operate the thermal controller circuit. With the digital thermostat temperature controlling module, right, I'm going to need these. These are metric free female spacer, electrical standoff, printed circuit board, hex screws, and these are 50mm long. Alright, and there's 4 of these. I've also got the metric free screws. Okay, you need 8 of these so that you can mount it onto the project box, and you can mount it, attach this onto the circuit board itself. So you need these as well. And part of my project box, because of the LED screen on the actual printed circuit board, I've included a 20mm by 40mm clear plastic 2mm thick perspex screen. Okay, this is already pre-cut. Okay, and basically I can put this over the LED screen and protect it. Okay, so I've got myself one of those as well. So the next item you're going to need is a sheet of 2mm thick by 100mm by 100mm or 100mm or 75mm sheet of aluminium plate. Now, it doesn't need to be thick stuff. You can use 3mm thickness, but just to keep costs down, 2mm plate is more than adequate. Okay, so you need a small piece of this. Now, this is very crucial because this is going to be your bracket you're going to make for your DSLR cooling mod. Now, this is very crucial to get something that's lightweight but also strong. And the reason why it has to be aluminium is that aluminium is a very good conductor of heat. And the good thing is, with the Peltier element in place, it will transfer the heat better, alright, and it will cool down the camera. So it's very crucial that you get a material that's got very good conductive properties for heat. So it's very crucial that you need to have this as an aluminium base. Now, you can use copper, but copper tends to be rather expensive. Now, these are copper plates, and these are already drilled to my specification. Now, these are metric free holes, okay, so I can fit my metric free screws in there, and they're all countersunk, so it'll fit nice and flush. Now, these plates are 75mm in length and 55mm in width, and there are two plates. Now if you can get one solid plate of the similar size, and again I have two separate plates here, one that's 2mm thick and the other is 3mm thick. Now I couldn't find a copper plate which is 5mm thick, which are very hard to find, and if you can find them, copper, like always, is very expensive. So alternatively I have to use two copper plates. Now the idea is, if you can afford a little bit of money, I mean this cost me about an extra £6 or £7 to pay for these additional items. But bigger the copper or aluminium plate, more conductive cold heat will hit the surface of the camera. So the more the surface area, the better the cooling is going to be. I really highly stress that, okay? You know, and with the extra cooling, with the more surface area to cool, okay, it's going to give you a good performance in cooling your camera. So ideally I need something just a little bit bigger, a lot more surface area, provide me better cooling. And just for sake of an extra £6, maybe £8 extra for these additional plates, you're going to get better cooling. So obviously if you're on a tight budget, then if you can't afford copper plates, then get yourself some aluminium plates instead. They'll still conduct the heat really well, but copper tends to be a lot better at conducting heat than aluminium. However, be warned, when you're working with copper, particularly with thicker dimensions, okay, like the 3mm thick, copper tends to be quite difficult to drill through. So the whole idea is be careful when you're drilling through copper. Don't overheat it, because what will happen is as the metal fragments heat up, because copper is a very good conductive of heat, when you're cutting through a drill bit through this plate, if you go in too hard or you go too much in depth and not let it cool gradually and then just work your way in, if you try to just keep on continuously drilling, what will happen is that the copper will melt and then start to seize up the drill bit, and then what will happen is it will just grab the drill bit and will stop it from twisting even more. So just be careful when you're working with copper. So ideally when you're drilling through this plate, just gradually drill bit by bit, okay, and just work it way in. Don't overheat it, because you start to get blurs around the edges, okay. That's when you start overworking with the metal. So just be careful when you're working with copper. It is soft to begin with, but as you more you work with this copper and the more you heat it up, the harder it gets. So it actually gets harder as you work more with copper, so just be careful with it. Alright, so just a little bit of advice. But top recommendation is, if you're going to have better cooling, you can't beat copper, and copper is just brilliant at transferring heat, especially if you want the cold heat. And this is why I would highly recommend that you get the copper plate instead. The next parts you're going to need are these. These are stainless steel 3mm thread, metric thread countersunk bolts, and these are 12mm long. Okay, you can buy these from a lot of good DIY stores, but you only need 4 of these tiny little screws. And then with those tiny screws, you're going to need the little nuts as well to thread into the metric 3 bolts. Okay, so you're going to need a few of these. Now I highly recommend that you use stainless steel. So this is basically attaches to my cold plate, and with these is, as it gets really cold, you start getting frosting and moisture on the actual plate itself. And what will happen is, with steel does actually corrode with age and start to rust. With stainless steel, they don't rust at all. So I would ideally, when you're taking the plate apart or for any maintenance or like cleaning up the plate itself, you're going to require to take these out occasionally. Okay, so you can clean up the plate, polish it up. So it's good investment to get yourself some stainless steel plate. Right, the next part is, it is an alternative. Get yourself some CPU thermal paste. Okay, you can buy this from Amazon. You can get a 20-gram tube for not much money, for about £3 or £4. Now this thermal paste is, the whole idea is when you connect all your parts together, you want to conduct the metal parts better in between. So any nooks and crannies and all that, this will fill up the gaps. For the sake of a 20-gram tube, it is well worth the investment, because what this paste will do will help to extract the cold heat better, and it will travel through between the plates. So it's really a good investment to get yourself some thermal paste compound. Wiring the electrical circuit of the thermal controller is very simple. Basically, you just connect the actual thermal couple itself, the actual sensor for the outside temperature, and it just clips in one way, okay, via a 2-pin adaptation, okay, and it just fits like that. Okay, it's relatively easy. Alright, that's that in place. Now, as you can see here, you have the fixed screws. Now, if we look closely, you can see where the couples are, you can see where the micro switches are. Alright, if you look closely here, you've got ground, you've got plus 12 volts, and you got K0 and K1. Now, ground is basically earth, and plus 12 is the red lead, okay? So you connect your main power to the 12 and the red and the black cable on there as well. So that's your main power line. The KA0 and the K1 connection is basically where your Peltier cooler and the fan is going to be connected in parallel along these ports there. Okay. So first off, we've got the cigarette adapter, and what we want to do is, now I'm going to install my female end of my 2.1 jack plug. But just for demonstration purposes, I'm just going to connect this directly onto the circuit. We're going to use a pair of pliers to just cut the outer cable. Okay, you just want to expose the bare cable, like so. We then connect the positive to the 12, like so. Using a flat point screwdriver, okay, and then connect the negative on the ground. That's the main power line connected. Then grab your fan. You're going to connect obviously the red and the negative lead. We're going to cut this part here, we don't need that. Okay, using the snips. Okay, we're going to just cut them off, we don't need that connector. And basically what we're going to do is we're going to spline these so we can get the metal on there. Okay, cut that, and this part as well. Okay, so you've got two bare wires there. So what I've done here is I've connected the complete circuit of the DSLR cooling mod. Is if we take a closer look, the ground port is your negative cables from your power cable and your Peltier cooler and your fan. That is connected to the ground. They are the black leads. If we go to the 12 volt connection there, that is your 12 volt power from your power lead. That is just connected there. From there, there is a spare wire which is bridged across. So you need to make an extra wire, a red lead, from the 12 volt to K1. Once you've got the bridge wire, you then go to K0, which is the positive lead of your Peltier cooler and your fan. That is connected to K0. That is now your completed circuit. So this is our completed circuit, and what we're going to do is we're going to activate it. The power's on the power tank and we activate the switch. Now what you can see is the fan working and the Peltier cooler, okay, operating. Now if we flip it over, it's really cold here, okay, the tech cooler here, right, this is the cold side. And here's the plan here, okay. This is the exact size of my drawing, okay. This is what the bracket's going to look like once it's fully made, okay. It's a rather simple bracket to make, and I've tried to do it in a way so that a lot of people can do it themselves. The good thing about this design, so if you cut this design out using a pair of scissors, you can actually make yourself a little jig. And here is a paper cut model of my jig, alright, and that's what the bracket's going to look like. Now the good thing about this jig is I can actually get my camera and then start to measure up, see how it fits. But I've already done that. I don't want to prove to you and waste time. Okay, I wanted to show you that this plate fits, alright, and by making this jig, alright, you can actually get yourself your aluminium plate, okay, and you can actually start doing the measurements, okay. So as you're cutting the measurements down, alright, you'll get the actual true size you want. So it will become apparent once I've marked it out first on this plate. And the good thing is, on the back of this plate, you can draw out your markings at the back of this protective sleeve, okay. So once you've got it all marked out, I'll proceed to the next step. So as you can see here, alright, I've drawn around my stencil, okay, I've got my jig, and I've drawn around the basic shape, okay, of that on my metal piece. And as you can see, what we're going to do now is going to cut this part here because we don't need it, okay, and we are going to cut along these parts here, and then we're going to carefully bend this part here backwards, okay. So once we've got that bent backwards, we can start doing other things to this plate. Also cut out the holes for the mounting of the 1/4 inch bracket bolt for the camera, and the holes marked out on the actual jig, and I marked it out on my aluminium sheet. So now what we're going to do now is going to cut it into pieces, and then we're going to start shaping it. So as you can see here, I've cut it down, okay, I've cut what I needed to cut, and I've cut down 2 slots, okay. This is going to be the bit where I'm going to hammer this forward to make an L shape. I will fire down all the edges to make it nice and smooth, okay, and get rid of all the metal blurs. Before I start bending that back, I'm going to make the holes already in place. So then once I've got done, that'll be the main bracket done. As you can see, even with 2mm thick aluminium, just be careful, because as you're cutting it, it will be hot, because it's a very good conductor of heat. So take your time, take it in steps, and then you'll get the desired cut you need. And as you can see there, I've gone past it slightly, but that's not to worry. Now, thicker that metal, more harder it is to work with. So just keep that in mind. Okay, 2mm fit is more than ample. So as you can see now, I'm going to put in my markings of my mounting holes, and obviously the main 1/4 inch hole as well. So this is the bracket. I've now drilled the 3mm holes. Okay, I'll make these slightly bigger if I'm going to screw it into my project box, because that's where it's going to go. Now I bent it back using a vise. Okay, I clamped the vise, used a hammer over the vise, okay, over a straight bit, or you can bend it by hand or use a hammer if you're not strong enough. Just tap it gently around something very around a right angle, for example, and just tap it around and you should have an L shape. Now as you can see here, I made a slight mistake because I drilled the hole on the wrong side. It does happen. However, I managed to redeem myself. Okay, it's not to worry, because the main thing is I might have two holes, but I've got one hole which I can line up my modified camera, and basically this bracket can now, with this 7mm hole that I drilled, okay, it does take a while to line it up, but basically I can just line it up to the mounting hole like so. As you can see here, it's lined up. Then I screw on my 1/4 inch bolt here. Okay, now this is just finger tight, and as you can see now, the bracket is now flush along the camera. You see now it's already sitting flush, and I can still operate the buttons without being in the way. So basically what's going to happen is, once I place this at all the other stuff, the electronic components on there, we're going to do it step by step so you get the idea of it. As you can see, it is actually quite a robust design. It's not going anywhere. Light as well, it's not added much weight to it. As you can see, it sits in there nice and flush, and that's what we want. Now we've got the bracket, the Peltier cooler, and we've got the aluminium and the copper plates. Now the whole idea of this design is that we want to position the Peltier cooler in between here, now at the back. So when we fit it in there, the Peltier cooler is going to be on this side. Now the reasons for that is, a lot of people thought, well, why don't you put the Peltier cooler here and put that in between? But unfortunately, what will happen is this plate here will warm up, and it will warm up because of the hot side. We don't want that to happen. We want the actual entire plate, including these pads here, which are going to get mounted at the back, and they're going to fit onto the back of the camera's body. We want the cold side only to just provide the cold air onto the camera body. We do not want the hot side. If we place that Peltier cooler in between there, we are going to get a lot of warm air. Now the whole idea is we're going to have the Peltier cooler mounted here, and we're going to mount the heat sink and the fan on this side. Okay, so you can see what we're doing. So basically this entire plate here will be cold, and that's what we're trying to do. We don't want any warm air. Alright, we want the heat shield to the heatsink to take as much heat as possible. The good thing about this design is, even at this base here, once I peel off the marking paper, the marking film, we get this part here is actually got a bit of an earth. So basically any cold air or any coldness will actually get to the electrics as well via through this part here. I'm trying to make a cooling system so that you don't need to strip out or the CMOS chip and trying to use a finger mod. Now the cold finger mod works really effective, but the main problem is though, when you start freezing electronics to really -degrees, you're gonna start getting moisture in your electronics. Now this will cool it down sufficient, very steadily, and the good thing is because the camera body is plastic and it will protect the actual electronics inside. So you're going to get the advantage of the cooling to minimize the noise level. It won't be as effective as a cold finger mod, but you can definitely be certain that it's not actually going to affect the electronics. And believe me, moisture and electronics do not mix. You do not want to add too much moisture into the electronics. Otherwise, what will happen, particularly in the CCD chip itself, when you're imaging, it will start to frost up, and you don't want that to happen to you, right? Okay, got my plate. What we're going to do is try and make things just a tad easier. I've just marked out my holes, and I'm going to drill out the holes at the back of the base of my plate. I'm going to mount the box first. Okay, so what we're going to do is going to use a few of these screws, right, and we're going to screw this at the back of project box. So we're going to use a screwdriver, use a Phillips screwdriver, and we're going to mount these screws in like so. Okay, and we're just going to screw them into the box. Okay, that's now the box fixed in now. So before we put our circuit in our box, first off, if you look here, I have drilled a 4mm hole on the top, and then on the bottom an 8mm hole. Now that's where the power point is going to go for the DC power cable, and then this is where the temperature sensor is going to go. Then if you go on the left hand side of the box, there is a 5mm hole that I drilled, and that's basically where all my cabling for my Peltier cooler and electric fan wires are going to go. What I've done is I've wired my circuit, and what we're going to do is before I start doing anything, a few alterations, I need to put in these brass inserts, right, for the for the printed circuit board. So we're going to fix these screws like so, using a Phillips screwdriver, get everything in place before we start mounting it into the project box. So also a bit of, you know, taking it easy. Okay, okay, so we start putting these in. Okay, that's them. That's the brass fittings in there. Okay. What the next step is, we're going with the DC power supply. I've cut the actual cable off. So now what I've done is I've cut all the major assemblies out of the way, so that I can literally rejoin them back together once I get this installed. The first thing I'm going to have to do is I'm going to have to solder this DC power socket first. So what I'm going to do is I've just cut the cigarette lighter power cables off. Okay, so you've got the bare wires, and now this is just an optional thing, but what you're going to do is with these cables, you've got the sockets, a female socket, and I've already found out which is the plus side and which is the negative side. And as you can see here, as we take a closer look, you see on the left hand side, right, that's where the positive lead goes on that terminal. So you've soldered that onto that terminal. On the top, right, that's where the negative goes. Right, so the negative goes on the top, right, and your positive lead goes on the left hand side. So basically what's happening there is that your terminal on the left hand side is the center pin, which is the plus, on the top is the negative. So, and also it's quite simple, bit of patience. Okay, and I'm just going to solder this terminal, okay, bit by bit, okay, and just keep. So we now soldered our connection, okay, as you can see now we've got on the left hand side the pos, which is the center pin, and the negative on the top, okay, that's the outer ring. Before we put it in the project box, we need to solder the male end of the cigarette adapter. So we've got a cigarette adapter here, and basically what we're going to do is we're going to solder the tiny middle pin first. That's where the positive is going to go, and then the negative on the outside, and that's what we're going to do now. So before you solder the cigarette adapter, make sure that you unscrew this out, and make sure, remember, don't forget to slide this cable through, the outer cable. So just a little handy tip to remember, just remember them and you can't go wrong, otherwise you'll have to recoat it and resolder it all again. So we soldered our two ends, so we've got our DC power and we've got our socket. What we're going to do is we're going to just test it out, okay, see if it works, right, and just making sure that we're getting power, okay, and that works. There you go. So now we've got everything assembled. We've got the socket in place, all right, the power socket and all that. We've got the fan connected, and we've got the Peltier cooling connected to the circuit board. So now what we're going to do is we're going to mount it, everything, pack it all in there, nice and easy. Take your time, don't take any loose connections out, and then we're just going to put the this bracket, this container here. So we're now going to put the buttons in place for our cover, but first we're going to put the O-rings in there, okay, for all our buttons, okay. You don't need to put them all the way in, okay, just put the O-ring, because the O-ring is going to be the retainer, alright, and you just put these 6mm aluminium buttons like so, okay, so they're in place, alright, and what we're going to do is we're going to grab our cover and carefully we're going to line up the buttons on the actual center console. Once we've got the buttons lined up, we can place our screen, or you don't have to install the screen, but if you wish you can install your screen like so, okay. And then what we're going to do is we're going to flip it round and then screw the screws, line up the buttons. So you're going to do is line up the buttons along these micro switches, okay, and when you slide them in there like so, make sure they're aligned with those micro switches first, okay. So now we've got the buttons lined up, okay, just carefully check each one. So we've now got the case back on, we check the buttons, see if they're operating, and we're now going to put the screws and fix this together. So I've threaded the holes from the back plate, as you can see here, with the metric free thread, and I've just marked out positions for the holes for the heat shield. So I'm just going to put 2 holes for the time being so I can get the Peltier cooler fixed in place. So I'm going to put 2 locating holes. So I'm going to fix this heat sink onto the Peltier cooler, alright. So now drill the 2 holes, okay. We're now going to screw this onto the plate, and then we're going to put some heat expansion paste. So we now put thermal paste on there, and there's thermal paste on both sides, and then we're going to screw that together. So we now got the heat sink fixed to the Peltier cooler. We're now going to fix the fan with the screws, and then we're going to put the handguard. So we're going to fix the handguard and the screws and screw that back in. And don't worry about if you damage the heat sink blades. What you're trying to do is trying to fix this fan. Okay, that's now fixed now with the screws. Got the guard on there. Okay, I think we're ready to go. All we got to do now is put the back plate on now. So before you start finishing off your DSLR cooling mod, before you install it, you need to make sure that with your copper plates or your aluminium plates, make sure you use a bit of metal polish just to clean up the surfaces on both sides of your plates. Okay, right, make sure on both sides of your plates are clean, and also with your other end of your cooling module, the actual DSLR mod, make sure that your aluminium plate is also polished. Also, things to look for is, if you look here, so basically what I've done there is using clear silicone, and basically I just smeared some around the cables where the drilled holes are, and then some at the back between the metal plate and the container box. And what that does is, as the plate gets cold, it will create a lot of moisture, and what that will do is that moisture will prevent the water from running into the controller of the electronics box. Okay, so any electrics and anything exposed will be protected with the silicone. So just make sure, just put a little bit of silicone just to waterproof it. You don't have to do it, but it's just to increase the reliability of your design. Okay, so it's very crucial you get that squared away. So what we're going to do is we're going to get ourselves our silicone or cooler paste or heatsink, whatever it is you like to call it. Alright, and you're going to smear it a film of this, some of this cooler paste, this heatsink cooler paste, all over this entire plate, like so. So again, you don't need a lot. Okay, you may get a bit of recess, but just mix it in. Okay, what you're doing, you're just going to mix all this in. Okay, and you're going to smear it everywhere. Okay, smear it around the edges, like so. Don't worry if you get it all over the bolts. Don't worry about that. But what you're trying to do is you're going to try and smear in this film of grease or paste all over the place. Then what you're going to do is, with your back plate, you're going to do the same. Okay, so with your back plate, you're going to smear at the back of that as well. Once you've done both sides, you then put both plates together. Okay, now just remember that the top plate does not require the heatsink paste, so just remember to keep that clean. Okay, now the whole idea is to use that paste so it all mates together and gives you a really good contact and give you a good conductor of heat. Now what we're going to do is use the metric free screws, and we're going to screw it all together. Okay, like so. Right, and just line it all up first. Okay, so line it all up. So now we've placed the screws and we're going to screw them in like so. Now if you put threads on there, you can screw them directly, but if you haven't got any tapping thread sets to cut the threads on the plates, then don't worry, you can use the nuts. So basically we're going to flip it over and you're going to put in the nuts at the behind it, and then you're going to tighten all the plates together. Now we've tightened up the screws. Okay, we're using the Allen wrench and our 5.5mm spanner. Alright, depending on what size bolts you use or nuts you use. Okay, tighten them up using and then what you do is, don't worry if you get the thermal paste everywhere around your modification. you can always clean it up. So again, once you've tightened everything and everything's in place, you then just clean off any abscess or any, if you get some of the paste that goes all the way around your modification, just clean it up. Once it's cleaned, once you've got it all cleaned up, you get yourself your camera. Alright, get your camera. Now the thing is, the whole idea of this modification is that you need to open up the viewfinder for the modification to fit inside that recess. You get your 1/4 thread bolt in hand, and what you're going to do is you're going to place the copper plate over and into the viewfinder slot. And as you can see, as you line up, you'll line up the hole that's already highlighted, okay, and you just line up the bolts, okay, like so. And then once it's in there, you then get your Allen wrench, like so. Okay, quick nip, and that's all it takes. Now as you can see now, the entire plate, the entire DSLR modification is now installed correctly. And the good thing is, where I've designed it, is this plate, the copper plate, sits perfectly inside that viewfinder. Alright, and that's going nowhere. Okay, so it's quite a good fixture there. With my sensor, basically what I've done is fed the cable through the bracket itself, okay, and basically I put the sensor, wrapped it with some electrician's tape onto the camera's body, like so. Now I didn't really want to strip out the camera main body, okay, I don't want to do that. I just want to basically just give me a rough indication of the actual temperature on the outside of the camera's body. I just wanted to do it on the outside, to be honest with you, and don't matter either way you put your sensor, as long as your sensor, I mean ideally you want the sensor to be inside the camera to give you a much more accurate reading of the actual electronics, and that's all it is. That's all I wanted to do. I didn't want to go strip it out into the main camera body. Alright, it's still going to do the same cooling effect. It's just that your temperature reading might be slightly out, but it doesn't matter. Okay, the whole idea is I wanted to fit it on the sensor at the back, okay, so it's out the way. Alright, so I just don't want to be messing about, and that's basically what it is. Alright, so I've put my temperature sensor there, and the good thing is, if the electrician's tape starts to come off, you can always just add some more. Alright, and that's all there is to it. So that includes the first part. I hope you guys and girls have followed through the guidelines, get the parts ordered and the equipment you're going to need to do the job. Look forward for part 2. That's going to be my findings. Okay, I'm going to test this camera out, test its performance, see how it goes, right, with the cooling module, right, and I will give out my honest reviews and comments on this DSLR cooling module, and that will be on part 2. We're also available for Facebook, the Facebook group, the Astronomy for Beginners. Please join that Facebook group. Alright, and if you like the videos and all that, please subscribe onto my channel. Again, hit the subscribe button based on astronomy for all you guys and girls who are newcomers and beginners, and for the experienced astronomers amongst us all. So again, please hit the subscribe button, please join our Astronomy for Beginners and be part of a national community for the budget enthusiasts. So again, thanks for watching, look forward for part 2, and clear skies to you all.